Hi, my name is Addison Altman, and I will today be going over sections 6 through 8 of the Unit 5 syllabus. So, before we learn how to write the chemical formulas for ionic compounds, we have to know what is an ionic compound. Ionic compounds, are ions that are held together by ionic bonding or the transfer of electrons between ions. So pretty much usually you have a positively charged cation and a negatively charged anion that come together and share electrons so they both have a full set of 8, or an octet, because the octet rule wants atoms to get a full set of 8 valence electrons. So in this case, because we want a cation and anion to bond to transfer electrons, we usually have a metal and a nonmetal in these type of compounds. So within these compounds, we have two different types. First are binary compounds. These are the simplest. They're compounds consisting of two different types of elements. So, for example, we would have sodium chloride, NaCl, or we would have something like barium chloride. Both of these only having two different types of elements within them, so they're binary compounds. Any ionic compound that has more than two different types of elements is a tertiary compound. So you might get something like sodium nitrate, which looks like this, or you would get barium phosphate, which looks like this. So within each, you have three different types of elements. You can't have more, but it's just more than two. So you have one right here, another one right here, another here. Then you have barium, phosphorus, and oxygen over here. So on the previous slide, you can see that there's a bunch of numbers here. How do I know what goes to where, and sorry. The order of things within the elements, within the compound, and writing the formula for it. So the first step is that you write it in the empirical form. Most ionic compounds are written like that. There's always a few exceptions to this rule, but those will not be covered in this video. So the empirical form is pretty much the simplest ratio of elements within a compound. What does this mean? So, for example, on the previous slide, I wrote NCl. In its simplest form, it's a 1-to-1 ratio, but I wouldn't write it as this when writing in ionic compound. Yes, it still has the same ratio as this. However, this first one is in its simplest terms, whereas this is not. So to be able to find the numbers of the ratios, you have to use the crisscross method. So pretty much you take the charge of one ion and cross it down, and that's the number of the other ion that you need within that compound. I know, it sounds a little confusing, but don't worry, we'll break it down into its simplest terms, empirical form, so you can learn it. So let's do a little example. So over here we have lithium. And then let's take oxygen, it's my favorite element, and do a little crisscross. So we're trying to make lithium oxide. So lithium is over here, it's in group 1A. So that means it has one valence electron. And because it is over here, that means it usually gives up that one valence electron for its full octet, meaning that lithium will have a charge of +1. And if you don't know how to do that, I would totally review how to figure out charges, because that is essential in writing these formulas. Then over here we have oxygen, who is in group, let me do some 6A over here. So that means when it forms ionic compounds, it wants to gain 2 electrons for a full valence set. So it would be L2 minus. So to crisscross, we would take the 1 over here and put it down here. And do I have other colors? Yes, I do. I would take the 2 up here and put it down here. We don't need to write this 1 because if there's 1 written, it's assumed to be 1, but we do need this 2. So to write lithium chloride in its simplified form, you would have Li2O. And because it's a 2-to-1 ratio, we can't simplify it any further, so this is our answer. So we always crisscross the charges to get our ratio. So let's do a little more practice because I know that might have been a little confusing. Aluminum will have a charge of 3 plus, and sulfide over here would have a charge of 2 negative. And if you want to know how to solve for those, I would review in previous units of figuring out what the charges are. Or, so if like you don't know what the charge is, you can look at it either 2 ways. You can be able to find it on the periodic table based on what group it's in. So, like all these over here form a +1 charge, here +2. Elements within the transition metals are not as easy to figure out, or they'll have a number next to them that will tell you what the charge is. And then over here, these will have 1 minus charge, 2 minus up here, 3 minus, 4 minus for carbon. 4 plus or minus. Then, so we would take the 3 up here from aluminum and the 2 over here from sulfide, and we would move them down to the other side. So aluminum sulfide, we would write it as follows: Al2 S3. And because we know this is a 2-to-3 ratio, we can't divide it any further, so it's in its empirical form. Next, we have iron 3 oxide. What I was talking about with the transition metals numbers, this is what I'm saying. So iron, I forget the chemical symbol, is Fe. Sorry. Fe, and we see that 3 up here. So that means it has a charge of +3. And then oxygen has a charge of 2 minus. Then we crisscross. And this will have 2. And this will have 3. So we take this up here, move it down here. And then we take this up here and move it down here. Oh, that was a bad arrow. Okay. So this is a more complicated one because this phosphate is going to have 2 elements within it. So calcium is, I'm going to change back to black. Calcium has a charge of 2 plus. And phosphate is one of those ones you have to memorize from the sheet. And I would totally recommend doing that ahead of time before learning these processes because it makes it a lot easier. So phosphate is going to be FO. And because it has an 8 ending, 4. And then a 3 minus charge. So we'll crisscross one more time. So Ca is going to take the charge up here, 3, put it down here. So when we write the charge, do the crisscross for the phosphate over here, we have to put parentheses around phosphate. And then put the charge of phosphate. Just like that. And that's your simplified version. It's a 3-to-2 ratio. So we know we can't simplify it any further. So let's pause the video for a quick second and try these 2 on your own. please pause the video and try to do them. Okay. So, potassium sulfide. Potassium has a charge of 1, and sulfide has a charge of 2 minus. Crisscross, and you should have gotten 2 Ks, 1 S. And next, this is calcium chlorate. So, Ca, calcium has a charge 2 plus. And then chlorate is ClO. It's in the elbow and has 8, so 3, and a charge of 1 minus. Crisscross, you should have gotten Ca2. Oh, no. No. Did that wrong. Ca should have just been by itself because it just takes the 1 over here. Ca in parentheses, ClO3. And then let me move me. Oh, okay. 2. And that's what you should have gotten. So, my only advice for going into these formulas is practice. Always learn how to know the charges and just crisscross and make sure you're simplified. And then you're good. Thank you.